Can you send that to me?
Sing a Christmas carol.
We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. Da, 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 da. I don't know the lyrics. I don't know the lyrics. We're making things up. I don't know what sing in the song. Why am I continuing? It's 40 seconds long. Thank you, Four different ways to make switches. So, number one, we have the classic push button. It just allows current to flow when you push the button. Number two, the relay switch. It's basically a box with a coil inside, and when the coil turns on, it flips the switch, turning on the different lights. Like so. Next, we have the latch. It can be used to replace the side switch if you don't have. So if I press this button, it's green. If I press this one, it's gonna be red again. But if I let go, it stays on green. Unlike when I push this, it goes back to red. Oh, the button disattached. Next, we have... I have to put my iPad down for this one. The potentiometer. If we twist it, it becomes brighter. And if we twist it the other way, it becomes dimmer. Obviously, I can't leave it on like that for too long or else it's gonna explode. And yeah, most of these, I use switch buttons to turn them on. Using switches, but hey, different ways to switch things, I guess. The annoying part of these small push buttons is because they come out really easily. Like this annoying. This is really annoying. You have to push it in like that. And anyways, that's it. Bye. This is the potentiometer, the button, and the active buzzer. Remember, active, not passive. So when I click the button, buzzer makes a sound, and then when let's actually put this down for a second. When I turn the potentiometer, it's really hard angle to do this. When I turn it, the volume goes up and down. Now, so the buzzer, obviously, it's just a buzzer. The button, it's a button. When you push it down, it allows the current to flow from positive to the positive of the buzzer. And the potentiometer, you can turn it to control the resistance. Wait, let me press the button. So here it's the maximum resistance, and as I turn it, so the potentiometer is just a resistor, but you can control the resistance. And that's it. Actually, yeah, we're pretty much done. This is the random circuit of the day. This is the SR latch, also known as the latch. If you don't have a side switch, you can make this circuit. It uses two transistors. Wait, these things that are behind the LED. Um, four, actually, six resistors. Two buttons and wire. Now, what does it do? Well, it basically does what a side switch does. So when I push this, it um it turns red. When I push this, it turns green, and when I release, it stays there. Unlike with a relay, when you release the button, it it just turns red again. So the core part of this circuit is the transistors. Now, transistors are actually pretty simple. They allow current to flow when current is going through their middle terminal. So, the middle is where what turns it on when there's current. And the sides are the input and output. Now, current flows from this to the button, and then when it gets to this, it turns the transistor on, which allows current to flow to the LED, and you get this. See, look, I'm not even touching it, and it is still on. And then when I want to turn it off, just turn it off. This can be used as an off and on switch, but if you have more transistors, you can use them to make an oscillating circuit, which can be used for Christmas lights and whatnot. Anyways, that is it. This is my name with LEDs. It uses resistors, wires, and obviously the LEDs. It is powered by my Arduino connected to my computer. It's my first attempt. Pretty cool. This is how the RGB LED works. So, if we put the leg, if we connect the jumper wire to any of the shorter wires, because there is a leg that is longer, the longer leg will be used for the negative. If we connect the jumper wire to one of the any shorter legs, you're gonna get a different color. So here we have blue, here we have green, and then here we have red. Red, green, and blue. That's how you use a simple RGB LED. And connected to this jumper wire is a resistor connected to positive, so it doesn't blow up. Anyways, let's just see one more time. Red, green, red, blue, green, no, green. for some reason the green LEDs look brighter, which I think is a combination of biology and electronics, because first, green is the color that the human eye is most sensitive to. And second, um, I don't know, maybe there's an electrical reason. But that's basically how you use an RGB LED. It's pretty simple. Just connect the battery to the longer leg of the longest leg of the LED, then connect the positive of the battery to a resistor, connect that to a wire, and then connect the wire to any one of the shorter legs. See, if I connect it to the longest leg, it doesn't light, unless of course I connect it to any one of the other legs. That is how you use an RGB LED. Thank you. I made another breakthrough. What a surprise. Oh, the camera sucks. Um, so before getting into this jumbled mess of wires, let's get into this small jumbled mess of wires. So here we have, I learned how to use buttons. Yes, I actually did. And if you push this button, that lights up. If you push this button, nothing happens. But if you push both buttons, you get white and then yellow. Now, the way buttons work is that it's pretty simple. They just allow current to flow when you push them. It just depends on what terminal you use. Like for example, the positive of the resistor goes through the button, and then the positive goes here when you push it, and then out into the battery again. Now this, where do I even begin? This was actually inspired by a Tinkercad model someone made. It's the red, the green, and then the blue. Red, green, blue. RGB. Now, the way it works is you get the positive, it goes through this resistor, and that goes into buttons, and then when you push it, the current continues flowing into this leg right, into the leg, which depends on which button you press. Then it goes out through this leg, and then back over to the battery. And that's about it. That's how this is my LED set up. It is 6 LEDs, the white, red, yellow, green, and blue, and RGB LED. To power this thing, we use the Arduino, which is powered by my computer connected by a cord. And currently it's not on yet because before we do the fiesta, turn off the lights. So now, if we connect the cable, oh, wait, there. This is all the LEDs, the white, red, yellow, green, and blue LEDs, as you can see. And then over here, you have the RGB LED. Wait, here we have the RGB or RGB LED, which actually has 3 different colors depending on what leg you connect. Now let's red, no, red, green. It's hard to hold green and then blue. And that's about it. Before we go, here, connecting the positive to the LED, we have a resistor. Don't forget the resistor, because if you don't, the LEDs will go pop. Anyways, that's it for this video. Bye. I made the circuit from the transfer task. Here's how it works. Oh. There. Wait, it's the ground. There. Okay, so yeah, there it is. Oh, the potentiometer. Okay, I'll put that. I'll show you the circuit. When I spin the potentiometer, the value changes. Look, this is the noise level detection system. I'll lower the brightness a bit because there. And then 0 there. Potentiometer is a bit loose, but it works. Okay, let's get the entire thing into view. There. Look at that. I really want you to see the display. Thanks to Zayo for making the code. Yeah, it works. It works. Anyways, bye. This is my wireless power transmitter. If I press the button, the LED turns on, but these two are not connected. And when I put this piece of paper in between the coils, the LED still lights, as you can see. No tricks, and actually there's no code. So, what's happening here? Basically, the circuit uses a relay and a capacitor to alternate a current through the primary coil. It turns it on and off really fast. And that generates a changing magnetic field. And that changing magnetic field generates a current in the secondary coil, which lights up the LED. Now, if you notice, I press it, the LED lights up, but when I flip the polarity, the LED should still light up. Why? This is because the output is actually alternating current, and the LED is actually turning on turning on and off really fast. It's just that we can't see it with the human eye. So I'll send the schematic diagram if you want to build it. All you really need is a button, a capacitor, a relay, and a power source. I highly advise using 9 volts instead of my Arduino's 5 volts because it gives better results. Thanks. So this is my wire maze thing. Let's have a go, shall we? It's really hard to do it with the iPad while you're holding the iPad, so if you if it touches, then
Matutulog na kami. Putang baho. Matutulog na kami. Huwag ka na
And I hello, look what I made. It's a number thing. It's a counter from 00, and then let's get 6, 5, 1, 2, 436, all the way up to 1023. Neat. Hi guys, I just want to show you a quick project I made. You can actually do this at home. Yeah, shocking, right? So, this is the wire maze I made. You can see, you move it, and if it touches the wire, it it turns on an LED and makes a noise. It's actually pretty hard to do with the iPad here, so let me try my best. Jeez, yeah, it is really hard to do with the iPad. Like holding the iPad in your other hand. Anyways, you might already know how the circuit works. Let's unplug this. So here, it looks like a jumbled mess of wires, but basically, the positive of this plug, the positive goes into the buzzer and the LED, actually through the resistor then the LED, and then it goes into the metal wire mesh through that wire over there. You might not see it, and then there's another wire connecting the handle, the holding thing, and when those two wires touch, they short the negative of the buzzer to the negative, so the buzzer and the LED turn on. So yeah, you could do this at home. You just need a few components and, of course, most importantly, a metal wire. So this is my electrical relay. When I close the switch here, it attracts this bolt, and you can see there is a wire here. The bolt is actually connected to this wire, connected to the bulb. Here it is. The bolt is connected to the wire here. That is connected to my bulb here. So when I close the coil, the sparks fly a bit. Let's get a better view here. And if I put a bulb here, short it, the switch closes and the bulb turns on. Now we are having a few connection issues because of the rusty metal contacts of the battery, but I actually already have a battery pack, so we might be able to use that. Or I might just sand off these edges here, so you can actually have better conduction. There. It's a relay. And of course, this is all part of my circuit board. Here's the battery pack I was talking about. That's the relay. It's supposed to turn on the light bulb. And these tracks are where the aluminum is gonna go. And these are the switches. So when you press them, the relay should turn on and activate the bulb. Mm-hmm.